In this video, we're going to look at practice problems 7 through 14 from topic 90. So how can you rewrite each expression? I'm going to go through this step by step. I'm going to show enough work. I might not show every step because there are 8 examples I'm going to try and get through here in one video, and I don't want to make the video too long. So number 7, let's look at the fourth root. 81 is a perfect fourth root, so we can leave that alone. The a value, a to the 8th power, 8 is already divisible by 4, so I don't need to change that. However, b to the 5th power, 5 is not divisible by 4, so I do need to change this to b to the 4th and b to the 1st power. Okay, so this b to the 5th is being split up here. All right, fourth root of 81, again, that is a perfect fourth root, so that would be 3. The fourth root of a to the 8th, a divided by 4 is 2. Fourth root of b to the 4th, 4 divided by 4 is 1, and the fourth root of b to the 1st we leave alone. That's my answer. Okay, that one was pretty direct. Only one variable had to be split up. Everything else worked out quite nicely. Problem number 8, we have a fraction inside the radical. I would always recommend reducing the fractions if possible. So what I'm going to do is reduce whatever I can. So we have the cube root. The 125, not going to be able to do anything with. The y squared, you're not going to be able to do anything with. However, I do have x to the 4th over x to the 1st. Remember that we subtract these, so that would be 4 minus 1, or just x cubed. So my numerator is going to be x cubed. All right, now I'm going to take the cube root of the numerator and the cube root of the denominator separately. So the cube root of x to the 3rd, 3 divided by 3 is 1, so that's going to be x. Y squared, the 2 is less than the index, so that means there's nothing that can be done with that. And then 125 is a perfect cube. We're just going to write that as 5. And that's our solution. Again, not so bad. Number 9, actually let me do some little highlighting here. This x cubed came from up here. Okay, so number 9, the cube root of 250 y squared, z to the 4th. 250 is not a perfect cube, but 250 is divisible by 125. So we're going to split that up. Y squared is already less than the index, so we leave that alone. Z to the 4th is not less than the index, so we're going to break that up into the cube root of z cubed and z to the 1st. All right, cube root of 125 is 5. Cube root of 2 we cannot take. Cube root of y squared we cannot take. Cube root of z cubed is z, and the cube root of z to the 1st we cannot take. All right, so from here, the 5 and the z are outside, so we'll put those together. And then all of the other terms are cube roots, so we can put those back under one radical. So 2y squared z. And there's nothing else. That's it. All right, moving right along. Number 10, the fourth root of 256. So what we have here. 256 is a perfect fourth root. You'd have to look at your list, but just take my word for it. The v value is going to be split up into v to the 4th and v to the 3rd, and the w value is already divisible, so we can leave it alone. The fourth root of 256 is 4. The fourth root of v to the 4th is v. The fourth root of v cubed is going to stay the same, and the fourth root of w cubed is, w to the 12th, get ahead of myself, is w cubed. So final answer, 4vw, fourth root of v cubed. Number 11, similar to number 8, I always recommend reducing your fraction before you can do anything else. 48 over 3, that is going to reduce, let me fix that, that's going to reduce to 16. The x values, we have x cubed over x, so 3 minus 1, which is x squared. That stays in the numerator. And then the denominator, we have our y squared value. Okay, so take the square root of the numerator and the denominator separately. This one's quite simple. We have 4x over y. All right, number 12, another fraction. Reduce it. So 56 over 7 is 8. We have x to the 5th over x. So 5 minus 1, that's going to be x to the 4th. And you'll have the same thing for the y values. So we have y to the 5th, y to the 1st, so it's 5 minus 1, and that's just 4. All right, 8 is not a perfect square. However, 8 can be split into 4 times 2. And then the other two, we'll keep them together. No reason not to. Remember the index, if it's not written, is a 2. So sometimes that's helpful to write in. It's up to you. Square root of 4 is 2. Square root of 2 we can leave alone. Square root of x to the 4th is x squared and y squared. So 2x squared, y squared, radical 2. Not so bad. 13, probably the easiest one here. 216 is a perfect cube. Cube root of 216 is 6. The m can't be simplified. That's our answer. All right, don't overthink it. Sometimes they are as simple and as easy as they look. Number 14, just like 11, 12, and 8, we're looking to reduce. So everything is going to reduce. So cube root 250 divided by 2 is 125. F to the 7th over f squared. I'm going to subtract to get f to the 5th. We have g cubed, that is a terrible g. G cubed over, that's not any better, g to the 1st, so that's going to be 3 minus 1, just g squared. I'm really struggling with writing g's today. There we go, that's a little better. So cube root of 125, cube root of f to the 3rd, f squared, right? We have to split that up. And the g value, the index is greater, so we don't need to change the g squared. So cube root of 125 is 5. Cube root of f cubed is f. And then the f squared and the g squared we cannot do anything with, so let's just put them back together. I think every g I wrote looks different in this problem, but we got the answer that we're looking for. So that's it. Practice them, keep applying the rules, look at your perfect squares, perfect cubes, perfect 4th, 5th roots, know how to get that list, and just make sure you're splitting up the variables the right way. I don't think you'll have too much trouble with this after some practice.